Hello everyone, I am Suman Ban. Here we learn about energy thickness in boundary layer. First we recapitulate boundary layer theory, displacement thickness and momentum thickness. When a real fluid flows over solid plate, which is stationary, then a thin layer of boundary formed in vicinity of a stationary solid plate. This is free stream velocity. This is a stationary solid plate. A thin layer of boundary formed in vicinity of this solid plate. This is boundary layer formation. There is velocity gradient inside of boundary. This is velocity gradient outside of boundary layer. Outside of means this is outside. This is a free stream velocity of fluid. There is no velocity gradient. du by dy is equal to 0. And inside of boundary there is velocity gradient. Some velocity gradient means at this point first layer of fluid velocity is 0. Second layer velocity also decreases. Third layer also decreases. Fourth layer also decreases. At after sub thickness of boundary, last layer of layer can free stream velocity. Free stream velocity is u this and this layer velocity also u. So there is no velocity gradient in outside of boundary layer fluid. In inside boundary layer, there is loss of mass, momentum, and kinetic energy. Means this is solid plate. This is free stream velocity of fluid. This is boundary layer formation. This is boundary layer thickness delta. Boundary layer thickness indicated by delta. So inside boundary, there is loss of mass per second, momentum per second, and kinetic energy per second. For compensating of this mass per second, momentum per second, and kinetic energy per second, matlab means loss of mass, momentum, and kinetic energy in this boundary layer, it will compensate these losses in the boundary layer. Same amount of mass of fluid flows with displacement thickness. Means this is plate, this is flow of fluid, this is ideal case of fluid flow. There is no formation of boundary layer. This is solid plate. After formation of boundary layer, how we compensate losses of mass, momentum, and kinetic energy of boundary layer? Here we see. This is boundary layer formation. This is free stream velocity. This is y. This is y. For ideal condition, this. But after formation of this boundary layer, this loss of mass, momentum, and kinetic energy, same mass of fluid, those losses in this boundary layer will flow this extended portion of boundary. We consider delta star. This delta star thickness where fluid flow with free stream. This delta star is called displacement thickness. Displacement thickness means same amount of fluid flow which losses inside of boundary layer. We consider losses of in this boundary layer fluid mass is 50 kilogram. Same amount of mass flow required at this thickness delta dash 50 kilogram. This type of compensation of mass in this delta dash displacement, it is called displacement thickness. In same manner, in same manner, this is boundary layer, this is solid plate, this is free stream velocity. Losses of momentum in this boundary layer zone, same losses of momentum will be covered by fluid flowing with this zone theta. This theta is called as momentum thickness. In same manner, fluid flow over plate. This is boundary layer formation. This is ideal case. This is ideal case of fluid flow, and losses of this energy in this zone will compensate by the fluid flow in this zone delta double star. In this zone, extended portion for compensating of this kinetic energy by this area fluid flow, that is called energy thickness. For calculating losses of kinetic energy in boundary layer zone, we subtract. Now, here we show this is boundary layer, this is plate, this is lead zone, this is free stream velocity, this is velocity distribution. Now we consider this is a small strip here. So first, energy thickness. It is defined as the distance measured perpendicular to the boundary of the solid body by which the boundary should be displaced to compensate for the reduction in kinetic energy of the solid fluid on account of boundary layer formation. It is denoted by delta. So this is solid plate. This is boundary layer formation. For compensating of this energy losses in boundary layer, same fluid flows outside of boundary. Amount of this loss will be equal to fluid flow in this zone. Amount of energy of this zone delta double dash is equal to amount of loss of this zone boundary layer. Consider the fluid flow over the plate having cross section 1 1 at a distance x from leading edge. At the section 1 1, at the section 1 1, consider an elemental strip. Just like this is boundary layer thickness, this is width of boundary layer. We consider a small strip whose thickness is dy and distance from plate top thickness, plate top by. This is BC. BC is boundary layer thickness. B is width of boundary layer. Fluid flow from this side and extract from this side. Here we consider same. This is elemental strip. Now we consider fluid flow. This is solid body, boundary layer formation. The losses of this kinetic energy in this boundary layer will be compensated by the fluid flow in delta dash energy thickness zone. মানে energy of this zone will be equal to losses of energy in this zone. Now we calculate losses of energy in boundary layer. Losses of energy in this boundary layer will be calculated by subtracting kinetic energy in delta thickness, जी मतलब boundary layer thickness fluid without boundary layer formation to kinetic energy in delta thickness fluid with boundary layer formation. Means this is boundary layer. Here we calculate energy losses in this boundary layer. How we calculate energy losses in this boundary layer? So energy in this boundary layer when no boundary layer found, and energy minus energy when boundary layer found, means kinetic energy in delta thickness मतलब boundary layer thickness. Delta thickness मतलब this is boundary layer and this is boundary layer thickness. So in kinetic energy in delta thickness without boundary layer formation, kinetic energy will be half m u square, mass of fluid half into density of fluid into fluid velocity inside boundary, breadth of fluid boundary, and thickness of this elemental strip into u square. Now, so kinetic energy in boundary layer when here consider no boundary formation. Kinetic energy in boundary layer without boundary layer formation will be this delta u b dy capital letter U, free stream velocity. This velocity of fluid inside boundary. This is a small u. Now consider kinetic energy. Now calculate kinetic energy in delta with boundary layer foundation. With boundary layer formation. Half mu square. This is a small layer, a small u. But the velocity of fluid inside boundary layer half into mass inside boundary u b dy a small u square. So losses of kinetic energy inside boundary layer. So kinetic energy inside boundary layer without boundary layer formation. Without boundary layer formation minus kinetic energy inside boundary layer with boundary layer foundation. Boundary layer formation means kinetic energy inside boundary layer without boundary layer formation minus kinetic energy inside boundary layer with boundary layer formation, that is losses of kinetic energy inside the boundary layer. Now here we calculate losses of kinetic energy inside boundary layer is equal to subtracting kinetic energy inside boundary without boundary layer formation with kinetic energy inside boundary with boundary layer formation. Now this will be half rho density U B dy. This dy is equal to elementum strip thickness. This is dy. This is width of strip. This is length of elementum strip minus half rho small u b dy. This is free stream velocity. This is velocity of fluid inside boundary. Small u, capital U. So this kinetic energy inside a boundary when no boundary layer formed. This kinetic energy inside a boundary when boundary layer formed. Then this subtraction find out loss of kinetic energy. Loss of kinetic energy inside boundary. Delta dash thickness distance by which the plate is displaced to compensate for the reduction of kinetic energy. Means this is plate, this is boundary layer formation, this is last layer of free stream. This is boundary layer formation. Here loss of kinetic energy. This loss of kinetic energy will be compensated when same amount of fluid, those kinetic energy will be this loss of kinetic energy. This fluid will flow at this thickness delta dash, and this delta dash thickness fluid kinetic energy will be equal to this kinetic energy. Those losses of kinetic energy, here losses of kinetic energy is equal to the this kinetic energy, this fluid kinetic energy, this zone. So this loss of kinetic energy will be calculated here, this difference. Now we calculate this fluid kinetic energy, delta dash fluid kinetic energy. Delta dash fluid kinetic energy will be equal to half rho b liquid flow in delta dash thickness, double star thickness. Here velocity of fluid will be capital U. Now half rho b delta star U. Here b u q half rho b delta double star eq. Now here this loss of kinetic energy calculated for elemental strip. Now this elemental strip vary to 0 to delta. Now total loss of kinetic energy for boundary layer thickness delta will be 0 to delta. So half rho this ub d by e square minus same term. Now this loss of kinetic energy will be equal to this kinetic energy, means this is boundary layer, this is fluid. This loss of kinetic energy will be equal to this kinetic energy which fluid flow with delta dash dash thickness half delta b delta star thickness uq is equal to half density u square dy. This is loss of kinetic energy inside boundary layer, and this kinetic energy is this thickness fluid. The fluid flow in delta dash delta double star fluid thickness. This fluid flow for compensating of boundary layer fluid loss. Now we calculate delta dash delta double star 0 to delta small u capital U free stream velocity. This is velocity of fluid inside boundary 1 minus u square capital U square dy. This is formula of kinetic energy thickness of boundary layer. Now here we learn